Hello everyone here, this is Eason from Think Academy Singapore. Today we are going to talk about extreme value in combinatorics. So last day we are talking about extreme value in calculations, which is a little easier than today, as in calculation we are easy to find how to make the formula the largest or smallest. But in the combinatorics, no. So sometimes we need to have a difficulty on finding the way to make it into extreme value, or sometimes the extreme sum may just not fit the limitation of the question. And last, some question may ask us to use some pigeonhole model, use the pigeonhole theory to construct the extreme condition. So yeah, each year there will always be one question or two questions about it. So let's have a look. Now the first question is the 2018 question. So it's only a 4-point question, but I don't think it's very easy. So there are 4 distinct numbers and in an ascendant order, maybe A, B, C, D here. And we know the smallest number and the sum of the other three's average, which can be written as B plus C plus D over 3. So here is a 39. Then for the largest number D, adds up the average of the other 3, which will be 51. So this is all we get, and now we should find the largest possible value of the largest number D. So first of all, so how to make the largest number as large as possible? We have that the sum is nearly determined, right? So yeah, we know this is 51, so should make D the largest, we should make A, B, C as small as possible. So now, first of all, we determine the direction. So D should be the largest and A, B, C should be as small as possible. But how can it be? Maybe can we let A, B, C just the O, 1, and 2? No, absolutely not, right? So because if you put 0, 1, 2 here and put it back, you will find that D has no solutions. Yeah, it's limited. So to find this limitation, first we should find the connection between these two formulas. It's similar for this formula as A, B, C, D occurs on each formula, and B and C all on the over 3. So maybe we can, first of all, tell the difference of these two formulas. So now here is a 3, B and C over 3. And A here, right? So there is 1 D, there is 1/3 of D, so there is 2/3 of D, also minus 2/3 of A. It's the difference of the value, which is 12. And then we can get D minus A's value to be 18. So by finding the difference of these two formulas, now we can get the difference of D and A. And now A should be D minus 18, right? Now we find the value of A. And don't forget, we should make B and C as small as possible. So now we determine the A here. So what is the smallest value B and C can choose? So don't forget, B should be greater than A. And for integer, greater means no smaller than A plus 1, right? So which means B, the smallest value B can use at least should be A plus 1, so which should becomes D minus 18 plus 1, so D minus 17. And for C, the smallest value for C should be B plus 1, which is A plus 2, which should be D minus 16. And this is the smallest value for B here, right? So yeah, this is the common thought. So we want something to be the largest, then we want the other thing to be the smallest. And yeah, we find the smallest number here, then we just make the other two to just be as close as the smallest and to make it the total the smallest. And then, yeah, we put it back, we will find that now A is a D minus 18, right? So here is a 3D minus, actually this is a 51 here. So here will be a 51. Make it to be 2D just should be equal to 68. And then D should be 34. So actually, so this is not, I think this is not an equality, right? So here, it's no greater than it, as B and C is no smaller than this formula. So this is a no greater, and here is no greater and no greater. So actually, this is an inequality. And now we find D should not be greater than 34, so the largest value for D is just 34 here, right? Now, this is the 2018 question. Not that difficult, but not that easy. So we should firstly find the difference between A and D, and then it's the extreme sort. We make B and C as small as possible, just A plus 1 and A plus 2, and then get the answer. Okay, now the next question is a pigeonhole theory. It's a 2022. Last year's question is 5 point. So, in a set of n 3-digit numbers, there must be, highlight the must be here. So, must be or guarantee. So, such word like this is the symbol of the pigeonhole theory. Or theorem, I don't know. Maybe a theory here. So, there must be 3 numbers that the sum of digits are the same. So this type of question is always a necessary thing to think at the opposite side. Which means that in this question, we should guarantee there are at least 3 numbers. So we think on the opposite side. So it said how many numbers as many as possible. So at most, how many numbers can we choose to not have 3 numbers, have the same sum of digits, right? So to do this, we may first classify all the 3-digit numbers with their sum of digits. So the smallest sum of digits should be maybe just 100, right? The smallest is 1. And maybe a 2, maybe a 3. All value can be taken. And for the largest, it should be a 27. As a 9 and 9 here, right? So there are 27 different cases here, right? And here we can use this 27 different cases as 27 pigeonhole or 27 drawers according to the pigeonhole theory. So the question is, we need to choose as many numbers as possible to make it no 3 numbers shares the same sum of digits, which means that in each condition, the number is a 2. So if we choose 2 from each of its kind, then this is the most number we can get where no 3 numbers share the same sum of digits, right? So this is the worst, maybe I think this is the worst condition that does not fit the need. And when we find the worst condition, we just use a +1 here. So if we choose one number more than the worst condition, then there must be at least 3 numbers, right? So this is how we solve this kind of problems. But however, so this worst condition has some problems. As there are 27 conditions, but we cannot choose 2 numbers from each condition, as there are 2 cases. For sum of digits with 1, there is only one 3-digit number that fit the need, which is 100. Also, for 27, there is only one number, it's 999. So, for these 2 cases, we can only choose out one 3-digit number, no more, right? For the other 25 conditions, we can always choose 2 different numbers from it. So actually, this is the worst condition. So in the worst case, we will have 1 plus 1. So totally, 52 numbers at most that does not have 3 numbers as asked. So if we want to guarantee what we need, we just plus 1 at the worst condition. So now it's 53. Here, 2, guarantee. Yeah, I forgot how to spell guarantee, so maybe to be sure. Yeah, this is a typical question about pigeonhole theory, and it's basic, but it has some trap in it. Okay, now that's all for today, and this is the end of our 10 days countdown. And you will have the NMOS Special Round at Tuesday, and hope you good luck, and wish you for gold medal. Thank you, and good luck.